Hello guys, you're welcome back to my channel. If you're on this channel for the first time, please click on the subscribe button and click on the notification bell to get updates on our latest video. Today we'll be considering energy emitted or absorbed by elements. Before we proceed, we'll do some calculations. So before then, this energy absorbed or emitted by elements, they are not scattered, they are in pack. So this packed energy, they are called quantum. They are called quanta. The packed energy, they are called quanta. So this quantum energy has a formula. The formula is given as E equals to h this, while our E stands for the energy emitted or absorbed, and this stands for the Planck constant, and this one stands for the frequency. And you know, from the knowledge of your wave, you have a frequency equals to what? C over lambda. You know that C, which is the speed of light, equals to the wavelength times the frequency. So substitute making your frequency, sorry, your formula. Now you have this. You get it right? Now our Planck constant has a value. The Planck constant has a value called 6.625 times 10 raised to power minus 34 joules second, and the speed of light has a value 3 times 10 raised to power 8 meter per second. That's the value for the speed of light. So now let me give you one hint too. 1 nanometer is equals to 10 raised to power minus 9 meters. So these are the parameters we'll be using in our subsequent calculations. So commit them to mind if you don't know them before. Now before we solve the question, let me make this clear. I told you E equals to H and frequency, and I told you our frequency is what? C over lambda. So we can substitute this C over lambda for our frequency here. So having the energy equals to H C, instead of putting this frequency, we'll put C over lambda. This is also a formula we're going to be using. So the question is, the first question says, calculate the ionization energy of an element ionized by radiation having a wavelength of 242 nanometer. 242 nanometer. So we are asked to calculate the energy emitted, the energy that is ionized by these elements. So we're given our, write out your parameters. You are asked to calculate the energy. You don't know, you are given your your wavelength to be 242 this. Now before you proceed, because you will be having your speed of light in meter per second, so that's 3 times 10 raised to power 8 meter per second. So for this, now we'll have to convert this to meter, and I told you 1 nanometer is equals to 10 raised to power minus 9 meter. So now 242 nanometer will be equals to what? So cross multiply, then you have your lambda to be this 2, this multiplied by this, you have 2.42 exponential 7 minus 7, sorry, minus 7. I hope you get it. You know, this is 1 2, so this 2, that's like 10 raised to power 2 multiplied by 10 raised to power minus 9. So your indices will now be 10 raised to power 2 minus 9, then you have 10 raised to power minus 7. That's how we get this 7 here. that's a meter. So now we'll use this formula here. We know our H, which is 6.625 times 10 raised to the power minus 34 joule seconds times the C, which is 3 times 10 raised to the power 8 meters per second, divided by our wavelength, which is what we have there, 2.42 times 10 raised to the power what? Minus 7 meters. So here we'll have this, we cancel this out, and per seconds we cancel this, so we are left with joule. That's the unit of energy. So our energy, this 6.625 multiplied by 3, let's do it like this. This multiplied by this 625 multiplied by 3, then multiply by the this minus 34, that's plus 8. That's your indices. You now have 2.42 times 10 raised to the power 7 here. Sorry for the marker. Now your E will be what? When you multiply by this, you're gonna have punch down your calculator, you're gonna have 19.87, right? Okay, multiply by, when you have this to this, you have minus 26, right? Minus 26 divided by this 2.42 times 10 raised to the power minus 7. Now our E, when you divide this 19.87 divided by 2.42, you have what? You're gonna have that's 8 point what? Let's punch that on a calculator. So that's 8.2, right? 21. Now this will have minus 27. When this cross to this side, it will be plus. To change to positive, so you have 8.21 times 10 raised to the power what here? Minus 19. Then joule. No, this joule that we have here, and that's it. You have your answer in joule here. So if you want to calculate, change this to kilojoule. No, of course, 1 kilojoule is equals to this joule. Then since we have this joule, now we'll have 8.21 exponential minus 19. So to give us what here, let's name it x. Then when you cross multiply, you'll have your x to be this multiplied by this divided by this. That's 8.21 exponential 19 minus 19 plus 3. That's what. Then you have minus 22 kilojoule, because this one, when it's divided by this power here, it will be minus 2. That means minus 3 here, so it will now be 22, minus 22. So this your answer in kilojoule. Now let's do this question. The initial energy of a given atom is 8.21 exponential minus 21 joule. Calculate the wavelength of the electromagnetic radiation, which is just enough to ionize the outermost electron of the given atom. Express your answer in nanometer. So from that question now, we were given our energy. Let's write out our parameters. We're given our energy as 821 times 10 raised to the power minus 21 joule. We are asked to calculate our lambda, that's the frequency, that's in meter per nanometer, We know our C to be 8 times 3 times 10 raised to power 8 meter per seconds, and our H is still remain the same, 6.625 times 10 raised to power minus 34 joules seconds. So now what we're gonna do is we know our E equals to HC over lambda, so we're gonna make this our lambda Sawyer formula. So what we're gonna do now, multiply both sides by lambda, multiply by lambda. So this will cancel out this, so you are left with E lambda equals to HC. So now we want to make lambda Sawyer formula, so our lambda equals to HC divided by E. So this is what we're gonna be working with. So now our lambda equals to H is 6.625 times 10 raised to power minus 34 times our C, 3 times 10 raised to power 8 divided by our E, which is now let's just convert this to points or to decimal so that it will be easier. That's 8.2112. Then we'll remove 2 from this. When you add 2 to this now, minus 21 plus 2, that's minus 19. Minus 19. So this is what we're gonna do now. So from here we have the lambda equals to 6.625 times 3 times 10. This minus 34 plus 8 is minus 26, right? Now divide by 8.21 times 10 raised to power minus 19, right? Now lambda equals to, when you multiply this, we get 19.87, right? Plus this multiplied by this divided by 8.21. I'm just gonna do it step by step so you're gonna understand very well. So lambda is this divided by this. Now we're gonna have 2.42 multiplied by 10 raised to power minus 26. Then when this crosses to this side, it changes to plus. That's your indices. So your lambda now is what? 2.42 plus this. So when you add this to this, minus 26 plus 19, that's minus 7, right? Minus 7. Now meter. But note, in our question we have to calculate our wavelength in nanometer. So you're gonna convert this now to nanometer. I told you 1 nanometer is equal to what? Good. Meters. So now you have this in meter. So let's say x nanometer, we don't know, equals to this 2.42 exponential minus 7 meter. So what we're gonna do now, cross multiply. So this multiplied by this and this multiplied by this. So our x nanometer now, our x will now be this multiplied by this, that's 2.42 exponential 7 meter divided by this. That's what? No, this one is in nanometer. So this multiplied by this will have 10 minus 9. So when you do this now, we're gonna have 2.242 multiplied by this minus 7 plus 9. You have what? 2. Now your lambda, no, nanometer. Now your lambda, you can, if you like, you can leave your answer like this, and if you like, you can go further and say when you multiply this to this, you cancel out the decimal, then you have this. This is your lambda. So the most important thing about this topic is you knowing how to convert your units. The transition between the units. That's what is very important. You have to commit that to mind. Now I'm gonna give you these exercises. So try these exercises on your own, and at the end of the video, you're gonna see the answer to them. Then you can cross-check whether you solve the questions well. That will help you to know, okay, now that you'll be bold enough to say you can handle questions pertaining to energy emitted or absorbed by elements. Thank you. Please subscribe to this channel, share these videos to friends, your colleagues, mates, let them also learn, and thank you. Answers.